Muted microphone. Amateur hour here. Hi. We're just going to have a short little stream today. I've been on site for Puffer. I post a picture in here. I did. I've been on site for Puffer. So, we're going to have some cool stuff here very soon. Going to have some machines. Haven't ordered the machines yet, and they're going to take a while, but I'm working on putting that together. Really, there are a few things I want to do today. Really though, the main thing is just there's this new experience buffer refactor that I tried to get some stuff done on over the weekend, but I was traveling, and of course I picked the hardest possible thing to work on to take with me traveling, not some like light easy work to catch up on. So we're gonna just look at it a little bit right now. I'll look at a couple of the things that I've done. Maybe we'll see if we can hack something together. I thought of a way of just simplifying it for now that'll probably be good enough. And yeah, we will go from there. We will go from there. I got like very, very little sleep, so today is just going to be getting back into it a little bit day. And then tomorrow, when I come back, we will have a full work day on this. And really over the next couple weeks, I'm going to try to like stream a lot, dev a lot, not have my schedule taken up by like too much bullshit. Really just try to crank it on Puffer. I want to work towards a 2.5 release, maybe a 3.0 release, depending on how big it is. We'll see what we version it. That's going to be the goal. And in order to do that, we need to have this file right here cleaned up fast and doing what we want. And it's kind of gotten a bit bloated. It's gotten a bit bloated. So there's all this crap here. Yeah, I think what we're gonna do is we're probably gonna stash some of this. Well, there's actually a lot of work here. I don't want to lose it. All right. We'll push that, and then I will pull down the work that I did over the weekend, and I will show you what we're looking at, because it's a pretty big change to the way that we are doing things, and I'm not sure I'm completely happy with it yet either, frankly. The idea is that we want to store... Hello, welcome, thank you. The idea here so right now we have this way of storing all of the experience in this flat buffer. The problem is that makes it really hard to do some new techniques that we're thinking about implementing. Also, it's a little bit slow because you have to sort the data before you train with it, and you have to like do this big index copy. So the goal is to come up with a way to store experience in segments. So you store in contiguous memory, like 128 steps from one environment or something like that. And we're going to try to just do that. Now, there are a whole bunch of edge cases where this thing fails, where the previous one doesn't. And I have some thoughts on how to work around it, but I think for now we're just going to do this and we're going to see what happens. I think that's what we're going to do. There are like absolutely ways for this thing to completely break, but I guess this is what we're doing for now. I mean, maybe I should think about it a little more before we go for it. I don't know. Yeah, I already have the code mostly written. I think it'll be more interesting to just start writing and see where this gets us. See advantages. Okay, so this is simple version right here. So this stores a 2D buffer of trajectories, trajectory length. That's all this does. I was getting some errors, but they might have been hardware specific. Let's see. No CUDA GPUs, lovely. I have to reboot this container. Okay. 1 second here. Shape of mask. Okay, at least we get a real error. And F lengths. Okay, so these are very different. How did I allocate this? There should be num rows, shouldn't it? Length of n by d is 1. This is quickly going to get very complicated. I kind of want to diagram some stuff out, because I don't trust myself to do this zero shot. I'm on good like 4 hours of sleep. Not peak capacity. not at all peak capacity. Okay, so we have this buffer where we're going to fill up data like this. And these are empty. There are a few different ways you can model this. Post a link to your Neptune ablation so I can steal charts. Yes. Hey, Captain. So the issue here, right, is when do you fill up this buffer? It's a very different answer if we're going to assume it's a puffer env versus any other env. We really don't want to break learning for everything that's not a puffer env. And I don't want two different buffers. And these are two very different ways you would implement this thing. Does this actually even do what we want? Let me think. So if you have a very long episode, how'd they do JE and Dota? And this is yet another reason we want to delete JE. It causes such pain. But JE is one of the things where, like, anything that I replace it is going to have similar infra requirements. It's tricky. Where's the sample thing? I was pretty sure they had a figure where they talk about their trajectory buffering. Yeah, right here. Okay, so 16 time steps times 16 samples is 128. Labeled together, JE, and sent to optimizer. So they're only rolling out, they're using 128 seconds. They're only using 128 steps, it looks like, right? To me, this figure says that JE is only computed backward over 128 steps. Four engine frames per policy step, so that's a frame skip. So it is truly 128 steps. They have to have played with that as well, right? Lambda stays 0.95. and JE horizon. And what's this? They listed this instead of the parameter. I don't have a comment on this. See equation 3. Okay, so they're just giving this to you in terms of the equation. But they're not actually doing this. So this is a little confusing here, right? This is a good find though. So they have this equation that's like 1 over 1 minus lambda or whatever that gives you the time horizon from the parameter. And they're saying that, look, that they're using JE over a horizon of up to 840 seconds, or 360 for a rerun. But if you look here, JE is only computing over 34 seconds. So they only get ground truth for JE over 34 seconds, and then the rest of it they have to be relying on the value function bootstrap. So if this works for Dota, I mean, this suggests to me that having some fixed buffer of 128 is a-okay in principle. Now, the only thing we have to deal with is like some of these not getting filled up. Realistically though, right? Is this going to be a big problem? I think realistically not. And here's why. So the fast M's in Puffer are all vectorized, and we're going to get like contiguous buffers of data. Is that true? Seems like it should be. What about the LSTM state? Okay, here, there's a paragraph on this. We train agents on 30-second segments of the game. And any given 30-second ground snippet may not contain the ground truth. We address this by training these heads in a similar fashion to how we train value functions. If a segment contains the ground truth label, we use ground truth label for all time steps. If not, we use the model's prediction at the end of the segment as the label. Oh, but these are just for the head predictors. I need to think about this very carefully. This seems like a fundamental problem, though. You can't collect more than 128 steps realistically, or it'll be stale. And I think data staleness is a bigger problem than anything. We also have to think about the historical replay here, because one of the ideas here is to add historical replay. How that's going to mess it up. Well, what do we need in order to compute advantage? Stone back off. I'm trying to think the best way to do a buffer of this variety. I mean, it's still better to store them in rows. As the networks get larger, well, we'll deal with that once we get to it. Can we just store this like in a different memory layout to make it easier? We probably could. So basically we would store it in roughly the format that we have now, like the final format we have now that's actually mini batched appropriately. I don't know if I like that though, because how do we swap in new data, right? I think our dim is like mini batch. What's our dim right now? Mini batches, mini batch size, PPO horizon. So it would be like all mini batches, a window of mini batch size, and all of this. No mini batches. It still doesn't fix the LSTM shenanigans either. Still doesn't fix the LSTM shenanigans. This is like rapidly getting very complicated. I don't want the code to be complicated. How do we think about this simpler? The simplest thing, I think, is just what I have now. And the current implementation should end up roughly the same as the next implementation, as the new implementation. I think it should. It is going to get awkward though if you want a longer BPT horizon. Yeah, see, they have this very separate here. This is the LSTM unroll, and this is JE. Whoops. So what you want is not 128. Okay, so that's off. I think I can do all of this such that the final code ends up being pretty compact. It's just a little tricky. Yeah. Okay. We can try this, and then Yeah, I think we just straight up we try this, right? LSTM state gets carried, but that's not a big deal. And other than LSTM get state getting carried, this should be perfectly correct. This will do BPT over arbitrary horizons, and we will miss like at most a few small samples. Let's do that. What are we going to do about lengths and indices? I guess we do it the slow and fully correct way first. So episode lengths is going to be num rows, and then this is LSTM total agents. And stored indices is num rows. And now num rows, batch size over horizon. Okay, this is good. So I actually had this mostly on my first pass. I just had to go through lots of different various alternatives. And the key thing is that we actually do have to do this tricky part here. So this isn't going to cut it. We have to do this part. Full IDs is env ID of full. Cool. It runs. I'm expecting to have broken everything. Yeah, so we did break everything. Kind of expected. But it does run. Cool. So the algorithm here that we have to get right, there's a couple pieces to this. So there's a whole bunch of indexing now we have to keep track of with this buffer to figure out essentially where we're storing data. We need to keep track of how long each segment is and which environment gets written to which segment. That is important. Not do here. Totally can. Eval has to reset these buffers, presumably, right? Every time you call eval, you have to reset these. Or on flattened batch, I guess. Let's just see what's happening. Okay, so first 2048 M's are done. Same IDs here. Pipelines get reset. That doesn't look right to me. $64. Something screwy here. How did we get 8192 out of this? Two M's, 2048 each. Should be 4096. Somehow we have double. How's this happen? $40.96, right? Oh, because that's, yeah, that is separate, okay. Yeah, that is separate. Fine. So this is actually, this looks good to me. And then you don't even need to do this either. Okay. $20.48. First 2048 M's are done. And explodes. Okay. What we're going for. Uh-huh. Why is free index 0? Could be like that. What in the heck? Oh no, is this not correct? It's all incredibly annoying because the M's are async. That's what it comes down to. The M's are async. It's very annoying. Got my guy building an N for circuits. Might stop by streams with questions. Really excited. Awesome. I'm half dead today from traveling at odd hours. So I do have pretty much from tomorrow for the next few weeks. It's going to be a lot of just me sitting here streaming and building stuff. So it's good timing. The new facility is going to be really cool. I got to figure out when I'm going to put the GPU order in. Whoops, hang on. And that's actually my call to end stream. Did prices go down? Prices should be going up with tariffs, I would think, but we will have to look at things. Anyways, I gotta go. I gotta get some food. I will be back probably tomorrow. Honestly, I'm exhausted. But the goal is going to be to get this new experience buffer working tomorrow and hopefully really clean up this file so that the dev branch can be like good usable code in addition to being ultra fast with all the new features. So thanks, folks. For those of you who dropped by, if you're interested in following this over the next few weeks, all my stuff's at puffer.ai. you want to help us out for free, start the repo. Really helps. And join the Discord to get involved. And other than that, follow me on X for more RL content. Thanks and see you around.